Hello everyone. Today we are going to discuss very important rule of a derivative, which is chain rule, which is very useful to find the derivative of functions. For example, a function is given y equals to sine of root x, which is composition of two functions. One function is sine function and another function is square root function. So to deal with these type of problems, we have to adopt one rule, that is called chain rule. What is the chain rule? Let us find out. Let y is a composition of two functions fx and gx. From here it is clear that f is a function of gx and g is a function of x. To find the derivative of such functions, we have to adopt this way: t dx of f of g of x, but we can differentiate function f with respect to gx, but here it is given that with respect to x, so let us change it with respect to gx, and then the function gx is, this function is function of x. Now we get this. If you using the Leibniz property, if we cut this, you will get this. But here we cannot use this Leibniz property. We can simply write this formula. We can prove it using the first principle. By that you can prove it. But here I am not going to prove it. I am going to find the differentiation of sine of root x. Okay. I think I am a little bit clear to all of you. Okay, let us use this function is given y equals to sine of root x, which is composition of two functions, sine function, square root function. So let us differentiate it with respect to x. T dx of y equals to d dx of sine of root x. Now sine of root is will be differentiate with respect to root x, because here the sine function is the function of root x. So I will write in this way: root x with respect to root x into root x with respect to x, using chain rule. Why chain? Because it's creating chain. Now as we know that the standard derivative of sine function is cos function, so here we will simply write cos of root x, this one using x to the power n derivative, so it will be 1 by 2 root x. So what will be the final result? 1 by 2 root x cos of x. So our final, now derivative of sine of root x will be this one. Let us try another example. Let us find the derivative of e to the power sin x. Okay, using chain rule. Here again it is a composition of two functions, so differentiating it with respect to x, so dy d dx of y equals to d dx of e to the power sin x. but e to the power sin x, this is the exponential function which is the function of what? Sin x. So we have to differentiate it with respect to sin x, and using chain rule sin x will be differentiated with respect to x. This will, by the standard formula, it will be e to the power sin x, and sin x will be cos x. So our required result is this one. Okay, let us try another, which is composition of three functions. Let y equals to sine of sec of tan of root x. Here this function is a composition of three functions: sec functions, tan functions, or square root functions. So using the chain rule, differentiating it with respect to x, we will write d dx of sec of tan of root x with respect to dx. Now since sec function is a function of what? Tan root x, this one, and tan is a function of what? Tan is a function of root x. So let us write it using the chain rule: dy by dx d sec of tan of root x, which is the function of tan of root x, into this tan of root x, which is the function of root x, into root x respect to x, using what? Chain rule. Okay, I have just simply using chain rule, I have written this one. Now what is the standard derivative of sec function? Is sec x tan x, that means sec of tan of root x into tan of root x. Now what is the derivative of tan x? That is the sec square x, but here we will write sec square root x. And what is the derivative of root x? 1 by 2 root x. So writing this, d dx of sec of tan root x equals to 1 by 2 root x sec of tan of root x, tan of root x, and sec square x. Thank you. If you have any doubt, you can send me. I will make it clear. Thanks.